Today I want to talk to you guys about flexible manufacturing systems. What is a flexible manufacturing system and what are some of the advantages of a flexible manufacturing system? I'm going to start off by breaking down there's two different types of flexible manufacturing systems, and you may have one of the two of these systems, and especially the first one. The first flexible manufacturing system is a system that is adaptable to different processes or different product ideas and even systems into your facility. So with the first type of system, where the system is adaptive based on the part itself or maybe some change in the process, this is a single system that is performing a process that is generally the same majority of the time. Maybe you need to run different part SKUs through it, different part numbers, and there's a few things in this system that makes it adaptive, right? Some of those things may include vision, so that way you can locate the different positions of the part. Maybe you have to change out fixturing, maybe there's tooling that holds the part during a welding process, or it's a pick and place application and the robot tooling needs to be changed on the robot head. And some of these adaptive systems can be engineered in different ways. One is a quick changeover method, where you press a couple buttons or you unscrew one lever and then the whole thing comes off. The whole fixture is able to be moved and changed out. Whereas a non-quick changeover option would be something where you have to remove 8 bolts or maybe even more to change out the fixturing. Then you have an automated changeover system where, let's say for instance, you have a robot, and within this process there's 10 different part numbers and you need 10 different robot toolings. So instead of somebody from maintenance having to go and change out the different robot toolings, the robot automatically changes to the proper tool without any human intervention. Which brings me to one of the next things that's required for these type of systems, and that's programming. The system has to be programmed to accommodate these things, right? The robot doesn't know just to automatically go pick up a different tool whenever somebody changes the part number. In the background, somebody had to do the programming to then tell the robot what tool it should pick up. How is that done? Well, on the back end, it's known as recipes. A lot of companies and operators may be familiar with the idea of recipes already, but essentially what recipes do is they give you the ability to have a part number and then associate different metrics of the system to be associated with that part number, right? A lot of times you can change the variables on the HMI, maybe you need different cycle times, maybe you need a conveyor to run longer for bigger parts, or maybe you need to have a conveyor run a shorter amount of time for smaller parts. You might want to have metrics like the color of the product saved. That way, if the wrong product color is being ran, the system can reject that or flag an alarm. So all these things are characteristics that can be added to a recipe. Going back to the robot tooling example, you could say part number X uses tool number 1, part number Y uses tool number 2, part number Z uses tool number 3. And in the back end, a programmer has taken that HMI interface, they've taken that data, saved it into the PLC, they then take that PLC data and then pass it off to the robot. Now that's all behind the scenes things that you don't necessarily have to know about. However, if you're on the controls engineering side of things, you probably already know or need to know these things. But the advantage to a manufacturer themselves is the fact that this system is changeable based on the operator's input. By them simply just changing the model number of one thing, and then all other things change within it.